Hello everybody, welcome back, and I'm delighted to welcome Martin from Sixonia, who's going to give us a very important presentation about the Holy Grail towards graphene commercialization, which I'm sure we're all going to find very interesting. So without further ado, I'm going to hand you over to Martin. Please do post your questions as we will be taking questions after the presentation. Thank you. Over to you, Martin.
Thanks, Chris, for the nice introduction. My name is Martin Lohe. I'm the CEO of Sixonia Tech. We are a small startup from Dresden in Germany, basically spun out of the Technical University of Dresden. And I will talk about our production process for few layer graphenes and how they might enable products or commercialization pathways that have not been really available so far. So, as you all know, graphene is a very promising material which has a lot of really amazing properties, but there have been a lot of challenges in the past, which are typically related to you have to usually choose whether you have a material that is easily processable, like graphene oxide, or which has a high quality, like a liquid phase exfoliated graphene in terms of defects, for example. And of course, if you have a material that is low in quality or that's badly processable, also the question of cost versus added value might appear. And especially in the past, I think this is something that most companies who have been active several years have now overcome, with also batch-to-batch consistency that has probably been deterring a lot of early adopters in the early days of graphene. So basically our mission is to overcome these problems, and I will explain you a little bit how we are doing that. So there was a recent survey done by the Graphene Council, which I found quite interesting, and they asked questions to graphene producers, graphene users, and people who are interested in using graphene. And basically, it turned out that there are some kind of characteristics that seem to be really, really crucial or really like the most demanded material. And this is, on the one hand, people want to have functionalized graphene. And the characteristics that are mostly needed are like good dispersibility and high electrical conductivity. So the question is, how can we achieve that? And if you look at traditional graphene exfoliation methods, like we're talking about bulk graphene materials, not really about CVD, you can basically use a physical process that is basically just introducing shear forces. And in a perfect world, these shear forces would be like nicely parallel to the actual graphite layers, and you would exfoliate nice graphene materials. But in the real world, of course, if you have such a process, these shear forces are going in random direction. And while the material is getting thinner and thinner and exfoliated, the particle size usually also gets smaller. So the lateral size is decreasing. And the next issue with such kind of process is that you're not changing the material. So it's inherently still has the same properties like the graphene layer inside the graphite. So it will also like to stick back together and form graphite again. And to overcome that, basically, you have to use surfactants. And with these kind of materials, you are potentially running into various problems. For example, if you're talking about composite materials where you want to have a very high conductivity, obviously the conductivity in the graphene itself will be extremely high because there's no defects. It's just a physical exfoliation method. But a small particle size will increase the influence of contact resistance. And obviously, if you have a surfactant that's not conductive by itself, you additionally increase the average distance between graphene flakes, which makes the electrons tunnel longer distances, and this will further increase the contact resistance. And the other point, if you're talking about mechanical reinforcements, if you have a material that is like inert, like graphite or a pristine graphene, you have very limited possibilities of interaction with your matrix materials. So the stress transfer between the matrix and the graphene could be a challenge as well. So if you talk about graphene oxide, which is basically the other main graphene product that is available and produced on really large scale nowadays, you usually have challenges like low conductivity because of the defects that you're introducing in the process, and also the process itself might be difficult to scale for many people due to the like heavy chemicals that are used, like permanganese or perchlorates that you need to deal with. So mechanical exfoliation I already mentioned. Usually you have you need to have a compromise. If you want to have very thin flakes, they are usually also quite small in lateral dimensions. And then if you have a very high purity material, usually it's difficult to process unless you can use surfactants in your process. That doesn't mean that these processes are not valid or not useful and these materials are bad.